Hi guys! So today we're going to talk about the Babylonian Numeration System, the Babylonian number system. And if you look at this chart right above me, you can see these are what Babylonian numbers look like. So this is the system where it sort of starts to get a little bit tricky. So we're going to take a look at it and break it down together. So the Babylonian number system was a bit more sophisticated than the Egyptian or Roman systems because it introduced the notion of place value, which means that the position of a symbol in a numeral determined its value. This made it possible to write numerals for very large numbers by using very few symbols. So we could basically write these really big numbers without having to use a million symbols, right? If you think about the Egyptian system, they had so many different symbols going on. Well, the Babylonian system only uses two sorts of symbols. So we have this little upside down triangle, which is equivalent to 1, and this little arrow that's like pointing to the left, that equals 10. So if we look down here at two examples, we have two of those arrows and one upside down triangle, so 10, 21, 21. And then here we have three of those triangles, or three of those arrows, excuse me. Each of those is 10, so 10, 20, 30, and then four of those upside down triangles. Each of those is 1, so this number would be 34. The Babylonians dealt in base 60. So we live in a base 10 world, right? We deal with base 10. Well, they dealt with base 60, okay? So in each of their place values, they would go all the way up to 59 before going to the next place value. We go up to 9, and once we hit 10, right, we make those exchanges and we go to the next place value. Well, when they go all the way up to 59 before they make an exchange because they worked in base 60. So they used a base 60 system, so the positions from left to right represented successive powers of 60, and multipliers, digits, were symbols for 1 through 59. So because we use base 10, we basically work within powers of 10. So we can compare these two systems. We can sort of draw this comparison with our system to make it a little bit more understandable. It can be really helpful. So if we look at our system, right, like if we look at the units place over here, that's our 10 to the 0 power because 10 to the 0 is just 1. Then if we move over to our tens place, which comes next, that's just 10 to the 1, the 10 to the first power, which is 10. If we look at our hundreds, that's 10 squared, which is 100. If we look at our thousands, that's 10 cubed, which is 1,000. Then we go to 10,000s in our system, that's 10 to the 4th, and then we go to 100,000. So you can see each time we move to a different place value, our exponent, our power of 10 is going up by 1, right? We go 1, 2, 3, 4, 5. So each time our power, we go 0, 1, 2, 3, 4, 5. Each time our exponent is going up by 1 because we deal with powers of 10. We work in a base 10 system. We're dealing with powers of 10. Well, the Babylonians, they worked in base 60. So they're not dealing with powers of 10, they're dealing with powers of 60. So if we think about a number in our system, let's say 5,432, right? Each of these numbers represents a place value, okay, a power of 10. So for example, the 5 in 5,000, that's 5 times 1,000, right? That's 5 thousands. The 4 in our hundreds place, that's 4 times 100. The 3 is in our tens place. That's 3 times 10. And the 2 in our units place, our ones place, that's 2 times 1, right? So if we break that down thinking about powers of 10, our base 10 system, well, 1,000 that we see in our that thousands place right here, this 1,000, where did that come from? That came from our power of 10, our 10 cubed. So it's really 5 times 10 cubed, right? Our thousands place is 10 cubed. Then if we think about our hundreds place, that's our 10 squared place value. So that 4 right here, that came from 4 times 10 squared, okay? We're thinking about our powers of 10. And then if we look at that 3, which is in our tens place, well, that's 3 times 10 to the first because that's our 10 to the first place value. And then lastly, if we look at our 2, well, that came from our units place, so that's just 2 times 10 to the 0 power. okay? So we're dealing with powers of 10. The Babylonians are dealing with powers of 60. So it helps to sort of think about it in our base 10 system because we know that so well. And then we can sort of use that to bridge us to that base 60 system. So let's take a look at a Babylonian number and see what it's really representing in our system. So here it says convert to Indo-Arabic, and it's really important for us to remember that, again, when we're dealing with Babylonian numbers, we're in base 60, which means we're dealing with powers of 60, okay? So we have a Babylonian number here, and now what we want to do is we want to take this number and we want to convert it to basically a number we know, a number we understand. So I've left white space in between each of these place values so you can see what each place value represents. The first thing I always do is I write my powers of 60, okay? So over here, if we just look at this section over here, that's our units place, okay? So that's our 60 to the 0 power place, all right? Which is really just representative of a value of 1. Okay, so that's why I have this 1 here. Then if we move over to the next place value, now we're in our 60 to the first place, which is really a value of 60. Then we move over to our next place value. Now we're in our 60 to the squared place value, which is really a value of 3,600. And if we move over to our next one, that's our 60 cubed place value, which is really a value of 216,000. And we could keep going. We could do 60 to the 4th, 60 to the 5th, but our number stops here, so this is where I'm going to stop with this. So I always write my powers of 60 and their values first. It's the first thing I do, okay? That's sort of the first step. Now I can move into my next step where I actually look at the symbols and start interpreting those. So if I remember back to the previous slide or 2 slides ago, we learned that these little arrows that point to the left, those are worth 10. And those little upside down triangles, those are worth 1, okay? So I'm going to look at my symbols now, and I'm going to figure out what I have. So I've got 2 upside down triangles, so that means I've got 2. So since I'm in my units place value here, that means I have 2 times 1, because remember, anything in this place value, however many I have in this place value, I need to multiply by its value. The value of this place value is 1. So if I have 2 in that place value, I'm multiplying 2 times 1. Now I'm going to move on to my next place value. And however many I have in here, I'm going to need to multiply by 60, okay? Because anything in this place value has a value of 60. So I've got another little upside down triangle, which is 1. So I just have 1 here. So it's just going to be 1 times 60. And now I'm going to move to my next place value, where dealing with a value of 3,600. So however many I have in here, I need to multiply by 3,600 because this is my 60 squared place value. So I have one little arrow pointing to the left, which is that represents a value of 10. So I have 10 times 3,600. And then if I move to my last place value, I've got 2 left arrows and 1, 2, 3, 4 upside down triangles. So that means I have 10, 20, 21, 22, 23, 24. Okay, and each of those has a value of 216,000 because that's the place value I'm in. So if you think back to the previous slide where we had our, I think it was 5,432 in our base 10 system, and we were dealing with powers of 10, we said that 5,432, well, that equaled 5 times 10 cubed plus 4 times 10 squared plus 3 times 10 plus 2 times 1, right? Those were my powers of 10. This is the same thing here, only now instead of powers of 10, I'm dealing with powers of 60. So instead of saying 5 times 10 cubed, I'm saying, well, I have 24 times 60 cubed, which is 216,000. So it's the same idea, only now instead of multiplying by powers of 10, I'm multiplying by powers of 60 and their associated values, right? If I were in our base system, this would be 10 cubed, which would be 1,000. And this would be the thousandths place value. And this would be 10 squared, which would be 100. And this would be the hundreds place value. And this would be 10 to the first would be the tens place value, right? So it's the same idea, just instead of 10, I have 60 now. So it takes a little bit of time to sort of wrap your mind around that. But once you practice this and you get going with it, you'll find it's a little bit easier to make that switch. So now I've taken my symbols, I've converted them into my different place values. And so I have 216,000, 24 times 216,000, 10 times 3,600, 1 times 60, and 2 times 1. I need to multiply those out and add them together to see what number I have. So 24 times 216,000, that's 5,184,000. 10 times 3,600 is 36,000. 1 times 60 is 60, and 2 times 1 is 2. If I add those all together, that gives me a total value of 5,220,062. Okay, so this is how much, so this Babylonian number, this is how much it actually equals. Okay, so when you do this, the first thing you want to do is write out your powers of 60 and their values. Then you're going to convert your symbols and multiply them by those values. Add it all together and you'll get your number. So on the next page, what I need you guys to do is to practice one on your own. So I want you to really pause this and really give it a try yourself before we go through it together. Really do it. So here's your number, your Babylonian number. I want you to pause the video, really, for real, and try it. Write your powers of 60 and their associated values. Okay, then convert your symbols, multiply, and add it to all. So pause the video and try it. If you haven't paused it yet, pause it and try it. Okay, so hopefully now you guys have actually tried this yourselves. So let's go through it together. So just like before, the first thing I'm going to do is write my powers of 60. Okay, so I have 60 to the first, which has a value of 1. Or excuse me, 60 to the 0, which has a value of 1. Then in my next place value, I have 60 to the first, which has a value of 60. In my next place value, I have 60 squared, which has a value of 3,600. And in my last place value, I have a value of 60 cubed, or excuse me, I have 60 cubed, which has a value of 216,000. So now I've got my powers of 60 and their associated values. Now I'm going to look at my symbols. So here I have 10, 20, 1, 2, 3. So 23. And then, of course, times a value of 1. In my next place value, I have 10, 20, 30, 2. So 32 times the value of 60. In my next place value, I have 10 and 1 more, which makes 11. So times the value of 3,600. And in my last place value, I have a value of 1, 2, okay, times 216,000. So now I need to multiply these out, see what I get. So 2 times 216,000, that's 432,000. 11 times 3,600, that's 39,600. 32 times 60, that's 1,920. And 23 times 1 is 23. When I add them all together, I get a value of 473,543. Guys, it's okay if this feels hard. It is hard at first, okay? It's hard working in a different base. You guys have worked in base 10 literally your entire lives. So of course it's going to be difficult to transition to base 60. It's like changing your way of thinking. That's hard. The best way to deal with a challenge, research shows, is through deliberate practice. That means basically practicing something that's hard for you. The more you do it, the more you practice, the better you will get at it, but until it becomes natural, okay? So go on to Math Lab. Math Lab lets you I let you redo these homeworks as many times as you want. Redo some of these problems. Even if you get it the first time, redo it, just so the process becomes natural. If you need to, reach out to me for more problems. I'm happy to provide them. Redo these examples from the lecture videos. Redo the examples that I'm going to leave in the content folder. Just do a lot. Practice it a lot, like with anything else. The more you practice, the better you'll get. And like I said, research shows that the way to improve your skill level on anything is through deliberate practice, which means practicing something that's hard for you. So just keep practicing and reach out to me with questions. I am so more than happy to help. So now let's take a look at how we would go the other way, how we would start with a number in our system and get to the symbols. So we're basically going to work backwards this time.